Yep, looks like we're up and running. Welcome back to the advent of syntran. This is day 6. So, I couldn't do yesterday. I can make excuses and say that I only worked on it for 2 hours, or my language doesn't have enough features, or I'm using an interpreted language so I can't brute force it like I could if I was using a fast, efficient, low-level language. But at the end of the day, I just couldn't do it. Hey, Kelly. That's my microphone. So, at the beginning of this series, I said I'll probably only make it like 3 to 5 days before I have to use some feature like recursion or structs that I don't have in syntran, and then I'll be stuck. Instead of being totally stuck, yesterday was more of a soft block than a hard block, so like maybe I could have figured it out if I worked on it all day or something, but I can't do that. I have a day job. So we'll find out today, are these problems just going to get ever increasingly more difficult, or are we going to get lucky today and have like a random easy problem? Let's find out. Let's go to day 6. It's day 6. I forgot what day it was. Okay, so they tell us how long each race lasts. Yeah, so that's the first line of input, and then the second line is the record. Part 1 seems easy enough. It could be like yesterday again, where day 2 is like nearly intractably difficult. We'll find out, but I think part 1 is doable. It's just a little physics and kinematics. Or is it kinetics? I think it's kinematics. This is like high school physics. Distance equals velocity times time. It's that kind of thing. Okay. Let's save the test input. Let's make a directory. What did I do here? Let's make day 6. Let's cd to day 6, or push d rather. let's save the test input. Okay, I did not save that file name correctly. .txt. There we go. And let's also save the real input. And let's take a look at that. That's not right. Oh, okay, yeah, it is. It's like it's only 2 lines. The real file has to be longer than that. It really is 2 lines, but we have different numbers here than in the test input. So this was the test input. It's not substantially bigger, it's just that the numbers are a little bit bigger. And we should be able to brute force this. We're working with integers, so we don't have to worry about holding the button like 1.5 milliseconds. You can either hold the button for 1 millisecond or you can hold the button for 2 milliseconds. So we're dealing with integers and we're dealing with a finite search space. This should be fairly easy to brute force. Maybe part 2 we'll have to do something that's more clever than brute force. But this is like a high school physics problem so far, so at least I understand it. Unlike yesterday, where like we're splitting these abstract lists of integers. So let's see if we can echo the input. Wow, my volume is way up. Okay, volume is turned down and there's the input echoed. So, each second that you hold down the button gives you 1 millimeter per second increase in speed, I think. Is that right? If you hold the button for 1 millisecond, then you travel at 1 millimeter per second. If you hold it down for 2 milliseconds, then you move at 2 millimeters per second. So it's a 1-to-1 ratio of increase in speed, depending on how long you hold down the button. Callie, please stay off my desk. Don't step on my keyboard. You might accidentally push something to GitHub. You're not authorized to do that. Okay. So, we really don't need a loop to read this file because it's only 2 lines long. So we read the first string, and we're gonna split it at the colon, and then we're gonna split by spaces, and then we're gonna get a list of integers. So we're gonna do that for the first line and get the times, and then we'll do it for the second line and get the distances. Hello, Mr. Fortran. Hello, Mr. Sorry, I don't know your pronouns. Hello, Bad Cop. Almost called you Mr. Bad Cop. Yeah, so let's read the first line and then split that. Not a Mr. All right. Welcome. Well, hello, Mrs. Bad Cop. Or Miss Bad Cop. These are distances. What did I have a helper function for? Yeah, this one seems okay so far. Part 1 seems doable. I'll find out if part 2 is like drastically more difficult like yesterday was. Nice break after day 5. Yeah. That's a nice change of pace. Utils. I know you're streaming. Did you complete day 5 or did you get stuck on part 2? I got stuck on it. I couldn't do it. Okay, parse I64 delim. That's what I want. And then it's gonna be that, and then split it by the colons. I have all of them so far. Congratulations. Yeah, I only spent 2 hours on yesterday. And after that, I was like, I'm giving up. I have to do one of these every day. I'm not going to get all of them, so there's no point just sinking infinite time into day 5. This is not dists yet. This is just a string. These are strings, actually. I get a vector of strings out of the... I can't call that yet. First I have to call split. So split by the colons, and then this will be distances. Split the strings at spaces. Okay. Oh, those are times, not distances. So I need to I need to rename that variable. And then we'll read the second line and do the same thing. Callie, you're not authorized to push to GitHub. Don't step on my keyboard. Don't drink my water. That's not for cats. It has citrus in it. You don't even like citrus. Okay, I can't see my screen at all right now. Callie, I can't see anything. Now this is distances. Okay, so we have times and we have distances. Are those right? Yeah, 9, 40, and 200. That looks correct. Callie really hates it when I stream. Okay, so we're going to iterate through the times and distances and figure out how many ways we can beat the record distance. So we can pull those elements out of the vector. So time is times I, and dist is dists I. Well, time is really the record time. Or no, dist is the record distance. So now I'm just going to transpose that table. And that loop didn't do anything. Did I save this? Oh, I just catted the input. Okay. So I have no spaces, but that's 7, 9, 15, 40, and 30, 200. Now we're going to test a few scenarios up to the time, because you can't hold the button longer than the race lasts. So we're going to iterate up through the race time. Do I want to rename this variable? Okay, that's a little more readable. So we're going to iterate up to the race time. We can skip 0 because then you don't move at all, and we can skip the race time because then you have a speed, but you don't spend any time moving. So in either of the extreme cases, you don't move at all, and you're never going to beat the record. Unless, is the record ever 0? No, the record distance is never 0, so we don't have to bother with those edge cases. I just said we can start at 1, and then this is not inclusive of the upper bound, so we're good on that extreme. Now, the speed is just going to be the duration that we hold down the button for. So speed is j. If we hold the button for 1 millisecond, then we start moving at 1 millimeter per millisecond. If we hold it for 2, we start moving at a speed of 2. So really, like, this is multiplied by some acceleration unit, and the acceleration unit is 1. Sure. Let's leave it there. Acceleration is 1 millimeter per millisecond, or 1 millimeter per millisecond squared. So we're taking a time, we're multiplying it by an acceleration, and we get a speed out of that. That's high school physics. Now, how far do we move? It's going to be the race time minus the time that we've spent holding the button times the speed. So duration is race time minus j, and then distance is speed times duration. And we should be able to see if this is correct. That didn't print anything. Race time. I did something stupid here. Oh, yeah, I'm parsing 64-bit integers, but I have some kind of weird bugs for 64-bit integers, and anyway, I can just deal with 32 bits for today. But I need to add a parser for that. Let's leave it there for consistency. If I just took out this casting function and I just did 0, then 0 would by default be a 32-bit integer. But for consistency with a 64-bit function, I'm going to leave it there as 32, and that should be the same thing. Okay, so we got a bunch of stuff. I think they gave us all of these numbers in the puzzle prompt, so we can quickly verify that those are correct. So you would travel 0, but we didn't do the edge case, so we have 6. No, so 6, 10, 12, 12, 10, 6. Those are the numbers that we got, so that's correct. And now what do we have to do? We have to count how many of these are greater than the record. There are actually 4 different ways you could win. In the second race, there are 8 different ways to win, and then what they want is 4 times 8 times 9, so the product of all of the possibilities of how many different ways we could win. So this is one of those rare days where they're asking for a product instead of a sum, but I refuse to rename my variable. I'm still going to name it sum. But for products, we have to initialize that to 0. You know what? Why not? Let's rename it. Okay, so product is initialized to 1, and then we have to count the number of different ways we can win. So let the number of ways we can win get initialized to 0, and if the distance is greater than the record distance, then we're going to increment that. And then outside of that loop, we're going to multiply the product by the number of ways we can win. So product times equals n win. And that should basically be it for part 1. 288. 288. Let's try that on the real input. It might take a little bit longer to run because we're brute forcing this, but we're dealing with things that are like tens or hundreds. We're not dealing with billions and billions like we were yesterday. So this still shouldn't take long to brute force. 220,000. Let's see if that's right. All right, that's got to be like a record time for me to get part 1. What was that, like 23 minutes? Because every day up until now, I've spent like the first 30 to 60 minutes just writing low-level string manipulation things to like split the input or parse an integer out of the input. But today I had most of those functions ready. I just had to copy and paste a 64-bit parser to a 32-bit parser. Not kerning. Okay, yeah, so it's a bigger number, and this is going to be something that maybe we can't brute force. I think I can still brute force this. Like, it's not that big of a number. Oh, but what I have to, now I need like a new string manipulation helper, so now I have to remove spaces from here. That shouldn't be too hard. How big is the input's not that big, so like I could do this manually. In fact, if I was like competitive in this and I was trying to solve this as fast as possible, I would just, you know, do that there. It's done in like 5 seconds, and now I don't have to have like a string helper function. Okay, so this is a 64-bit integer. The distance, but the time 59 million. That's really not that big. I should still be able to brute force that. But we do need a 64-bit integer to represent this number. But I'm not going to cheat, and it's not cheating anyway. The person who's number 1 on the leaderboard probably did exactly that, unless they already had a function ready to go that removes spaces. Yeah, so part 2, we're going to copy and paste part 1. Okay, now this should just, let's go back to the test input. Okay, this should just run part 1 twice. Now we have to remove the spaces. I'm not going to make a general search and replace function because that might be non-trivial. It's easier just to write a function that removes a character. So I still want to split this. But then I want to remove spaces. I might be lazy and just not rename this variable, even though it's now time singular. Do I want everything to be 64-bit integers? Because the times don't have to be, but the distance does. I think it should work. And then what is inside of here? This is the string, but with all the spaces removed. So I'm going to have like an rmchar function. And that's going to be strings1, and then we're going to remove the spaces. So now we need to implement this rmchar function. And this will return a string. And we're going to iterate character by character, and if it's not the thing that we're supposed to remove, then we're going to... I don't have... I can concatenate strings. Let's be smart. Let's implement this efficiently. And let's make the string the maximum length that it could be, and then trim it once at the end. Because if you concatenate a character one at a time, like a bunch of times onto a string, that's not really efficient. That won't scale very good if your string gets super long. So I want to do this the right way. We're just going to set it to the input string, and that's as long as it could possibly be. And now we're going to go character by character and shuffle things around. So if the current character of the string is not the character that we're supposed to remove, we're going to add it to, or put it into the output string. I don't have a not equals operator for strings, so I have to do it like this. Then alt j equals stri, and then j gets incremented. Now at the end of this, we're going to trim the string. So alt equals alt 0 through j. I might have an off by 1 error, but I think this is correct. And this will return. Right, times is now a scalar, so you can't get the size of a scalar. That's not valid. Basically, we're not going to have this for loop. I'm just going to comment out the whole thing for now because I'm not ready to run that. I just want to see if my space removing function is working correctly. Is this? Yeah, this is part 2. Okay, so all of these numbers have been concatenated together. Now we have to do the same thing for the distances, or the distance. There's only one of them. So this one has to be 64. This is parse I64. And again, we're going to remove all of the spaces. So the record distance is just all of the distances concatenated. Let me double check that. So 940,200. Yeah, that's correct. And we don't have any off by 1 errors. We have the last character and we have the first character. So everything that should be there is there. And now it's the same thing as part 1, but we don't need a loop. So uncomment most of this and unindent it, and we don't need a loop. So these things are not arrays anymore. There's just one time. I should rename that variable, but renaming things is just an opportunity for bugs. So if this code works, I'm not going to change anything. Yeah. I didn't have to bother with this acceleration unit because I thought for part 2 maybe the acceleration is going to change, or like it's going to be some non-constant function of how long you hold the button. But they didn't do that, so this code looks stupid now. But we should be able to brute force this pretty fast for the test input at least. And I think I have some kind of 64-bit bug. Oh, no, I just catted the input again. Okay, so we have a lot of ways that we could win. That's for the test input. Let's comment out some of those prints. And then just try to brute force the real input. If we can't brute force it, this math isn't that complicated, so I should be able to solve it. It took like 7 seconds with all the printing. And it's a lot faster if you don't print all that junk. So let's try the real input. Could take a little bit, but remember, we only have to iterate up to this number. We don't have to iterate up to this number. and this is like 59 million. That's not really that big. Even a slow interpreted language like syntran should be able to brute force it. If we had to iterate up to this number, then we would be in trouble. But fortunately, we don't. I don't know how long this is going to take to run. But let's give it a few minutes. Maybe we should start thinking about how we could solve this without brute forcing in case this just runs for the next hour. It only took 2 minutes to run, and I got 0. That doesn't seem right. Did I get this right for the test input? So with the test input, it was 71,503. 71,503. Is the answer actually 0? No. It was worth a try. How? Oh, I have a 32-bit 64-bit problem. So yeah, this overflowed, and then somehow the result of overflow and casting back to a 32-bit integer is 0. I think that's what happened. So this is going to take another 2 minutes. And let's make sure this works on the test input before I try it again on the real input. So we have to initialize the product. You don't even have to multiply anything because there's no product of multiple things. It's just one number. But I'm curious. This should be some kind of runtime error. Well, I don't know. No, because if you stop to check for overflow every time you do an operation, you kill the efficiency of your programming language. So maybe there should be like a debug interpreter which would catch things like this, but for a release version, the correct thing to do is not check for overflow every time there's an operation. Let me make sure the test input works. Okay, that's still the same number. Let's run it for real and wait another 2 minutes. I'm feeling so lazy today. I do not want to implement the clever non-brute force solution. Because, like, if it saves you 2 minutes in an interpreted language, what's the point? I feel like the puzzle makers are trying to trick you into optimizing things that you don't need to optimize, because if you saw day 2 and you're like, oh, I need to be clever and I can't iterate through like a billion things, then you spend a bunch of time trying to be clever, whereas you could have just written sloppy code and gotten the answer in 2 minutes rather than spending like 5 to 10 minutes coming up with the fast way to do it. So it's not faster if it takes you longer to write the code. It still says 0. Okay, let me print the other number. Dist greater than. Oh yeah, this overflows. Two more minutes. If I got it right the first time, this would have been more efficient, but now, there we go. Why did that run so fast? That's part 1. Two more minutes. I don't remember when I started running this. It's probably been like a minute. Third time's the charm. Still says 0. Didn't I put in an extra print statement? Oh. Is this casting the wrong way? Okay, 4th time's the charm. 64-bit integers are very new in syntran. The first type I had in this language was I32, and I worked with that for like 8 months. And then a few weeks ago, it was like, oh, Advent of Code is coming up. I know, like, at some point within the first week, they're going to make me use 64-bit integers. So I very, very hastily added these to the language, and clearly there are a lot of bugs with casting. Once again, I failed to keep track of when I started running this. I know that comparisons work between 32 bits and 64 bits because I've tested that. If we look at my tests, yeah, I do things like cast a number to I64 and then compare it with a 32-bit integer. So I've tested all of these permutations, and I know that these work. It looks like what I haven't done, I've tested like big numbers comparing to each other, and I've tested small numbers comparing to each other, but I've never tested like a big number being compared to a small number. I should probably add some tests for that. How is that still 0? Okay, yeah, this is where the overflow is happening. So one of these needs to be casted up. Maybe both of them do. And let me double check that with the test input one more time, since this is going to take like 2 minutes to run. Okay, that's still the right answer for the test input. Let's give this another 2 minutes. This is taking embarrassingly long. Like I said though, like I64s are brand new to the syntran language, so of course I have all kinds of unexpected bugs. I keep expecting one of these to take a little bit longer than, it's not actually 2 minutes, it's like 1 minute 45 seconds. So this was the test input. It's like 1 minute 45 seconds, but every time I cast something up to I64, those mathematical operations become a little bit more expensive. So I'm thinking one of these might take longer to run, but so far they've all been like 1 minute 45. $59 million is really not that big though. If I was doing this in a low-level language, this would be done by now. And if I had to run it 5 times to fix 5 different bugs, it still would have been done like 10 minutes ago. All right, finally something that's non-zero. There we go. I probably saved, I don't know, if I thought about it from the beginning and just wrote some code that worked from the get-go and solved like the quadratic formula or whatever it is to find the 2 extreme cases where you can just barely win and then take the difference to count the number of ways that you can win. Maybe I would have done it faster. I don't know. Maybe it would have been a wash. So I'm going to get this committed. And then I'm going to feed my cat because she's hungry. What am I typing? So we added a couple helper functions, and then we added everything in this directory. I like to add the year too, because I might do like multiple years in this repository. So I want to have the year in the commit message. So it's been 52 minutes, according to my clock at least. This is record time for me so far in AOC 2023. Let's make sure that that pushed. Wait, day 5, it's day 6. I almost never force push, but I'm gonna force push this just to fix the commit message. This is day 6, and then I have to do push-f. This is rewriting history. You should never do this in code that like anybody else is using, but this is my personal repository for advent of code, so it doesn't really matter. There we go, there's the correct commit message. And here's the code that we wrote today. The terrible brute force code, but it only takes 2 minutes, so who cares? It only takes 2 minutes if you get it right the first time. If you do it like me and you have to run it 5 times, it actually took me 10 minutes of running code. All right, that's it for today. I will catch you next time.